Okay, let's continue with the topic. Okay, there comes two theorems in the moment of inertia topic. Okay, so that is parallel axis theorem and perpendicular axis theorem. Okay, let's start with the parallel axis theorem. What does this parallel axis theorem states? Okay, so this theorem states that the moment of inertia of a plane figure about an axis 1 1 parallel to the centroidal axis. Here x is the centroidal axis, parallel to the centroidal axis. Then I bar x is equal to the sum of moment of inertia about centroidal axis. Okay, that is I bar x and the product of area of the plane figure and square of the distance between the two axes. Okay, so let us write the statement. It is bit lengthier. Okay, so it states that the moment of inertia of plane figure about an axis I1 about an axis 1 okay, which is parallel to centroidal axis. Okay, so that is I bar x is equal to sum of moment of inertia about centroidal axis. Okay, so that is what you can write I bar x and the product of area of the plane figure and square of the distance between two axes. Okay, so this is the statement of the parallel axis theorem. So how this statement can be proved? Okay, so for that let us consider a plane figure. Of total area A as shown here. Okay, then let I bar x be the moment of inertia about x-axis. Okay, so about x-axis I bar x is the moment of inertia, and then I11 be the moment of inertia about 1 axis, and this is about x axis. Okay, let us consider them. Then let us choose an elemental strip of area dA, at a distance of y from the centroidal axis. Here x is the centroidal axis and 1 is the reference axis we have taken. Okay, then moment of inertia of the strip about x-axis can be written as what? As we know that it is first moment of area into perpendicular distance, that is ax square. So here area of the elemental strip is how much? dA into perpendicular distance. This is the strip which is having a area dA. What is the perpendicular distance about the centroidal axis? Y. So dA into y square is the moment of inertia of the strip about x-axis. Similarly, moment of inertia of total area about x-axis okay, xx axis, that is centroidal axis, is equal to summation of dA into y square. Because see, this is the area of small area which is having dA, okay. So if you take the total area, it is summation of like this small strips, okay. So that we have taken summation of dA into y square. Now moment of inertia of strip again about 1 axis, axis, it is equal to dA into, what is the perpendicular distance here? About 1 axis, y plus y bar, okay. So dA into y plus y bar whole square, okay. Similarly, moment of inertia of total area about 1 axis is equal to dA into that we have taken about a moment of total area about 1 axis, so which can be written as I11, okay, is equal to summation of dA into, okay, dA into this y plus y bar square can be written as y square plus y bar square plus 2y into y bar, okay, 2y into y bar. This can be written as summation of dA into y square plus summation of dA into y bar square plus 2 into y bar into 2 into y bar into summation of dA into y, summation of dA into y, okay. So now as the distance of CG of, okay, see here, as the distance of this CG of the whole area about the centroidal axis, is there any distance? This CG is lying on the centroidal axis itself, so hence there is no perpendicular distance. What happens? Y becomes equal to 0, okay, y becomes equal to 0. So therefore we will get I, okay, here summation of dA into y square is nothing but I bar x, okay. So I bar x plus summation of dA can be written as total area A into y bar square, okay, and this term will become equal to 0 as I said that. So the distance of CG of the whole area from the centroidal axis is 0, okay. So I11 is equal to I bar x plus A into y bar square, okay. Similarly, if you consider, okay, the moment of inertia about an axis 2 2, about an axis 2 2 as shown in this figure, okay. So we get what? I22 is equal to I bar into y plus A into x bar square, A into x bar square, okay. So this is the proof of parallel axis theorem.